to find the difference between the natural key and surrogate key, their advantages and disadvantages. The advantages of a surrogate key is decoupling from the business, and it helps to have indexes to be as small as possible and shallow and results in shallower B-tree indexes. If you join, the joins would be faster using fast full index scan, and one can have a common codification strategy across all entities so as to reduce the total cost of ownership by writing less source code. Key updates like natural key values do sometimes needs to be updated, but surrogate keys will not be updated. If a natural key is used as a primary key and the key gets updated, then the same updates needs to be cascaded across all the child entities so as to have concurrency across the database. And moreover, when a natural primary key is used and it gets updated, the instance itself gets changed. That is, overall, the identification criteria for the instance itself gets changed. And this particular change needs to be propagated to all the child tables as well. That is the reason why we have referential integrity rules, which will help us cascade the changes from the primary key changes to the child table. Or it may even help us restrict the updation of primary key using the RI action. So if key update is an issue, surrogate key is a better choice. The disadvantages of a natural key is it is effective, it is tightly coupled with the business. It has a business meaning, and the moment business gets changed, the natural key will undergo a change, and one has to rework the natural keys. So it is always useful or beneficial to have surrogate keys as primary keys so as to isolate it from the business. The numbers are not short. Okay, the resulting natural key may not be short. It may be a combination of many attributes and may consist of complex data types. So the indexes which would be created over them will not be efficiently used, and hence the performance issues can be over there, since the entire index is based on mixed data types, or longer or higher, or overall index will have a greater width. Now the disadvantages of surrogate key. I am sure no one has ever imagined about the disadvantages of a surrogate key. And a surrogate key is not a human readable, or it's not suitable for human consumption. And hence, since they do not have any business meaning, so you might still need to implement alternate keys for searching and editing. That is, the primary key would now, the natural primary key will now become an alternate key within the same entity where we are using the surrogate key. Index maintenance is a problem, would be not a problem, but would be an additional task which needs to be done, because in general it is necessary to index the natural key regardless of whether the surrogate key, primary key is present or not, because natural primary key would still be used for searching a record uniquely using some kind of screens from the application. So a surrogate key increases the index maintenance overhead, inserts and updates and deletes. If a surrogate key is used, the natural key is not available in the child table. As a result, for any information of those natural key, one has to do an extra join back to the parent table and retrieve the necessary columns. Partitioning happens mostly on the natural key, and surrogate key severely limits the available partitioning strategies. That is, the range partitioning or the list partitioning is difficult to happen. However, one can just partition them across, or using surrogate keys. Disconnected inserts. Now to use surrogate key in a distributed environment with disconnected nodes that needs to insert records, each node needs to generate a mutually exclusive range of key values from its own sequence generator. The allocation of key ranges needs to be carefully managed, whereas there is no such consideration if a natural key is used. This is pretty much straightforward that when you have disconnected inserts in a distributed environment, then each node has to be carefully given a certain exclusive, mutually exclusive range of key values which a sequence generator can generate and not overlapping values. In a distributed environment, surrogate keys are not favorable unless a global unique codification strategy or scheme is implemented. Now, alternate keys. For alternate keys, we must first understand what are candidate keys. So, there can be more than one column that can serve as a primary key in a particular table, and these primary keys or these other columns which can even serve as primary keys are called as candidate keys. Candidate key is a minimal set of attributes that functionally determine all the other attributes in a relation or a table. So, the minimum set of attributes that functionally determine all the rest of the attributes of a table or a relation, and these are called as candidate keys. Candidate keys that are not primary keys are known as alternate keys. The definition is very simple out here. Candidate keys which are not primary keys are designated as alternate keys, and they are often used to identify different indexes which can be further created to access data more efficiently. After selecting primary keys from a list of candidate keys, one can choose alternate keys. Primary key is always chosen with consent of the business because it is the business who knows its data very well and better than data modeler. Alternate keys are not part of primary key or foreign key, and in a data model, an alternate key is designated by ek of n, that is, A stands for alternate key, while n stands for the alternate key group number. A particular attribute can be a part of two groups. For example, over here, employee name and employee birthday together forms an alternate key. So we have ek1 and ek1. However, employee name and employee hire date can again become another alternate key where we will have employee name will follow ek1 comma ek2 and employee hire date will have only ek2 out here. So that's another alternate key group which is created. Inversion entity attributes. This is the non-unique index which is being created. Okay, unlike primary key and alternate key, an inversion entry is an attribute or a set of attributes that are commonly used to access an entity, but it may not result into finding exactly one instance of an entity. It is non-unique in its nature, and in a data model, they are represented by the symbol IE of 1 or IE of n, where n is the inversion entity or inversion entry group. By assigning an attribute to an inversion entry group, a non-unique index is created in the database. So an attribute can belong to an alternate key group as well as inversion entry group. Example is shown out here where employee birth date and employee name is part of an alternate key group, while employee name itself which can be a part of an inversion entry group. Foreign keys. Guidelines for defining foreign keys would be: foreign keys enforces referential integrity by completing association between two entities. Every dependent entity or a category entity entity or a subtype entity must have a foreign key. So these are all weak entities, that is the dependent entity or the subtype entity or the category entity which are related, which uses foreign key to establish its relationship with the parent table or a strong entity. A foreign key is a primary key of one entity that is contributed to or duplicated in another entity to identify instance of a relationship. A foreign key always matches with the primary key of another entity. This is very important definition. A foreign key always matches with the primary key in another entity. A foreign key may or may not be unique, and generally it is not unique because the child entity has multiple instances of that particular of instance of a particular instance in the parent entity. The entity in the foreign key is called the child entity. The entity with the foreign key is called the child entity, while the one with the matching primary key is called the parent entity. In a one-to-many relationship, the parent is on the one side and the child is on the many side. Foreign key values. The foreign key value occurs in the table where the attribute is primary key and again in the other table. This conflicts with the idea that a value is stored only once. However, using referential integrity constraints or RI rules, we ensure that the fact is represented across the database only once. That is, logically the fact is represented only once, though physically it may be occurring in the primary key of the parent entity and the foreign key of the child entity. However, they are tied through referential integrity via the relationship which is created, and any change in the primary key of the parent entity will be either restricted or cascaded, restricted or cascaded, and the same effect will be transferred to the child entity or the foreign key of the child entity. Hence, data is always consistent and concurrency of data is maintained. Hence, we can say that there is no compromise of the fact that a fact is stored once and it is not duplicated across the database. So a fact is stored at one place at one time and there are no duplicates. Though physically there are duplicate values which are there, but through RI rules, that is the referential integrity rules, we still maintain the facts we still logically maintain one fact at one place. Domain of an attribute, also known as the value set, the complete set of possible values that a data element can be assigned is called the domain. A domain is a valid set of values for an attribute which enforces those values from an insert or update that makes sense. Domain includes data types, length, date format, range, constraints, default values, null values. It is a part of the integrity constraint or validation requirement of a data. So a domain is actually puts certain more restrictions on the kind of data a particular column can withhold. And this is determined by the data type, length, the format, range, nullability of that particular column, any constraints which are defined, and the default values which are defined or assigned to that attribute. Domain is a list of permissible values for a attribute. It is the property of attribute and it may be defined by listing the values, by data types, by default values. The value that will be recorded if a value, what is the default value? It would be the value that would be recorded in the absence of a user input. That is, permissible default values are a legal value from the domain, a none or a null value, or required or not null. For a required or not null kind of attribute, no value from the domain is common enough to be default, but some value must be entered. So in those cases, it would be some kind of default value which needs to be inserted for a required column. Generalization or subtype relationship is uh, like subtype relationship is a kind of weak entity. We have already seen the definition in the previous slides. A subtype relationship is also known as categorization relationship. It is a relationship the, between a subtype entity and its generic parent. We can see that either we can have checking amount saving account or a loans account, or we can have a generic account entity which can be further specialized into checking account, savings account, and loans account. By doing this, the common attributes of the account, for example, account ID, account open and start, open date and a close date, can be actually taken from the specialized entity like checking account, account and loan account, and can be put and bundled together into the account entity. When to create a subtype relationship, entity shares a common set of attributes. That is what we have discussed. Entity shares a common set of relationships. For example, if each account type is related to many customers, you can include a single relationship at the account level and eliminate the separate relationship at the individual subtypes. So this is quite explanatory. And purely for communication enhancement, one can use this supertype and subtype entity. Now for IDF1X, there are complete and incomplete subtypes. In an incomplete subtype, which indicates that the modular field, there may be other subtype entities that may not yet been discovered, but may crop up later in the development project. So an incomplete subtype is indicated by a single line at the bottom of the subtype symbol. We see those symbols now. If the subtype cluster does not include all the possible subtypes, every instance of the generic parent is not associated with one subtype, then the subtype cluster is incomplete. Then what is a complete subtype? Which indicates that the modeler is certain that all the possible subtype entities are included in the subtype structure, and a complete subtype is indicated by two lines at the bottom of the subtype symbol. So in IDF1X, subtypes within a subtype cluster are mutually exclusive. There are no overlapping subtypes. While unlike IDF1X, IE notation does not distinguish between a complete and incomplete relationship. Instead, IE notation documents whether the relationship is an exclusive or inclusive relationship. So a complete or an incomplete subtype is more specific to IDF1X notation, and an exclusive and inclusive relationship is more specific to IE notation. However, IDF1X notation distinguishes between complete and incomplete subtype and not exclusive or inclusive. So over here we can see exclusive subtype with two lines at the bottom of the symbol for complete, and for incomplete subtype there is only single line at the bottom of the symbol. IE notation for it would be X. The X in between states that it's an exclusive subtype. For an inclusive subtype, there is no X written over here. And for an subtype with IDF1X notation, there would be an inclusive subtype with over here in this way. Since it is incomplete, there are double lines or double dashes below the circle. Over here it is incomplete, and hence there is a single dash over below the circle. This is how one can depict depict exclusive subtype relationship, okay, in the IE notation, exclusive subtype relationship in the IE notation. However, the same thing can be given in IDF1X using complete and incomplete uh, values or complete and incomplete notions, as you can see over here. This is most important slide, and it will enhance the understanding of the entire generalization concept. That is generalization and specialization. It is the two sides of the same coin. Generalization would be rolling up while specialization would be rolling down. Subtype relationship or generalization. What is generalization? Generalization means factoring out commonality among attributes into a separate entity and creating subtypes or supertypes and inheritance. So generalization is also known as subtyping or supertyping or inheritance. And a generalization hierarchy is a structured group of entities that share common attributes, while the subtypes will have special entities, special attributes which are pertaining to that particular subtype. While the supertype entity will have generic attributes which are common across all the subtypes. Generalization is the relationship between an entity and one or more refined versions. The entity being refined is called a supertype, and each refined version is called a subtype. Generalization is also called a is-a relationship. That is, savings account and current account is a account. So savings account is the specialization or the subtypes which are created. That is, savings account and current account is a account, which means is a supertype. So subtype is a supertype. That is how we can read this. Generalization hierarchy should be used when a large number of entities appear to be of the same type. Attributes are repeated for multiple entities and the model is continually evolving. That is, generalization hierarchies improve the stability of the model by allowing changes to be made only to those entities germane to the change and simplify the model by reducing the number of entities in the model. These are the few uses or advantages of a generalization hierarchy. So when a model is continually evolving and let's say there is a change in the saving account interest rate. So you need to go ahead and change the interest rate only in the saving accounts and not in the current accounts or the accounts table. And hence changes or what would I say? The changes are made only to those entities which are germane to the change and the rest of the model remains stable and flexible. Subtype relationship to construct a subtype relation to construct a generalization hierarchy stepwise process. All common attributes are assigned to the supertype. Assign an attribute called as discriminator, which is an additional attribute to the whose values identify the category of the subtype. Okay, attributes unique to a category are assigned to the appropriate subtype. Each subtype inherits the primary key of the supertype, and subtypes that have only a primary key should be eliminated. Subtypes are related to the supertypes through one-to-one relationship. Types of generalization hierarchy: overlapping subtypes and disjoint subtypes. In a overlapping hierarchy, an entity instance can be part of multiple subtypes, while in a disjoint subtype, in a disjoint hierarchy, an entity instance can occur only in one subtype. So for subtype relationship, that is generalization, let us see what are the rules of generalization. The primary rule of generalization hierarchy is that each instance of the supertype entity must appear at least once, at least one subtype. Likewise, an instance of the subtype must appear in the supertype. Subtypes that can which are part of can be part of only one generalization hierarchy. That is, subtype cannot be related to more than one supertype. Generalization hierarchies may be nested by having subtype of one hierarchy be the supertype of another. That is cascading effect of the generalization hierarchies. And for nested generalization, subtypes may be the parent entity in a relationship but not the child. If this were allowed, the subtype would inherit two primary keys. What is specialization? So subtype relationship in specialization means it is also a kind of subset hierarchy where we create special cases for a given entity. Specialization is a process of defining set of subclasses of an entity type. This entity type is called superclass of the specialization, while those specialized entities are called subtypes of that particular subtype relationship. So specialization allows classification of an entity into subsets based on some distinguishing characteristics or attributes. The subset may have some additional attributes which are specific to that particular subtype. Purpose of specialization is to have or is to detail additional specific behavior of these specialized entities. It is possible that there may be entity instances that do not fall into any of the specialization entity. For example, you have created a generic employee entity which is specialized into part-time employee and full-time employee. How about contractual employee or freelance employees? And this is something, when it is not there, it provides more room to create more specialized entities. Specialization provided a more detailed picture of data and enforcement of more business rules, but less stability in the face of changes to these rules. So, it provides less stability in the face of changes to these particular rules because of which a specialized entity is created. Generalization, however, provides fewer entity classes, fewer rules in the data structure, and greater resilience to change. So specialization provides a more detailed picture. It actually enforces more business rules. However, it is less stable to the changes made to those business rules for which a particular entity is created. Generalization, on the other hand, creates fewer entities. Fewer rules can be depicted in the data structure, and greater resilience can be obtained in the face of changing environment. So specialization is a kind of roll down, while a generalization is a kind of roll up. Over here you can see in this particular diagram below, we can see that employee is bifurcated into faculty and non-faculty employees. Okay, the faculty and non-faculty is a employee. This is the subtype or the relationship which is created. When we create specific entities or specialization entities over here, we can roll it up towards generalized entity or generalization. Okay, so employee would be the supertype and faculty and non-faculty are the subtype. We can roll up or roll down. That is, we can do a generalization on the way up by putting attributes of this faculty and non-faculty inside the employee table and then using a discriminator column to identify a particular instance of employee is a faculty or non-faculty. Or else one can roll down the common attributes of employee and duplicate them into faculty and non-faculty employee and have a specialized entities created. So faculty and non-faculty can have a general entity called employee. In the payroll application, the two entities are treated together Here the common attributes are factored out to define employee entity and specific attributes are incorporated into the faculty and non-faculty entity. Similarly, over here employees are into two disjoint subsets, that is classified and wages. Over here we are trying to depict an overlapping subtype wherein a person can be a faculty as well as student, okay, or a person may be a faculty or a staff as well as a student. Rolling up and rolling down. The generalization hierarchy can be rolled up or rolled down depending on the following conditions. Depending on the conditions, rolling up means removing the subtype and copying all the data elements and relationships from each subtype into the supertype. And one needs to also add a type code to distinguish the supertype. Rolling down is nothing but removing the supertype entity and copying all the data elements or duplicating the data elements across the various subtypes. And one can see the effect of roll up and roll down over here in the below diagrams. And I leave it to your interpretation and understanding the roll up and roll down. Here you can see the roll up model. What all things are the advantages and disadvantages of a roll up model? One can pause the video and actually go through these particular things. In a roll up model, there are less number of database objects to maintain and queries are simple. By rolling up, data modeler is forced to make all the subtype columns optional or nullable. Data modeler have to use another means for like check constraints or application code to enforce the column optionality. Nullable foreign keys exist and a data modeler has lost the ability to reflect some of the business rules into the physical model. When you create a roll up or a roll down transform, its logical partition of data by horizontal or vertical partition transform into the resulting table. That is what is roll up and roll down. Roll down model, factors influencing roll down are data volume in the supertype entity, better manageability, no triggers, no constraints, no complex code, easy to understand. Also business rules are made explicit. Roll down enhances performance, no triggers, no constraints, no complex code and easy to understand. Business rules are made explicit. Roll down model are generally normalized at third normal form. Roll down avoids nullable foreign keys. And these are the advantages and disadvantages of this particular roll down process. I leave it to the interpretation of the audience and make a move to the next slide, which is the 4 rules of modeling relationships. 4 basic rules for modeling relationships, like all entities which are involved, all entities must be involved in a relationship. There should be no orphan entities which are not linked to the entire model. Too many relationships with a bridge table. Transform complex relationships into binary ones. There should not be any ternary relationships or ternary entities which are present, and eliminate redundant relationships. That is, those relationships which are having the same meaning or an equivalent meaning or as long as the other relationship. That is, a relationship between a department assigned to a many workstation is the same as department assigned to many employees and the employee in turn assigned to many workstations. So over here, the upper relationship between the department and workstation seems to be redundant, and this needs to be eliminated. So a redundant relationship is a relationship that is equivalent in meaning to another relationship between the same 2 entities. So physical data model. Here we come to the objective of a physical data model is to provide a database administrator with sufficient information to create an efficient physical database. So the objective is something one needs to understand, that it is to provide the DBA with sufficient information to create the efficient physical database. And what is the sufficient information? It is the volumetric information of the entities, the relationships, their cardinality, and also the table space information to which a particular entity belongs to. So this is the physical data model provides a context for the definition and recording of the data elements that forms the database and assist the application team to choose a physical structure for the program that will access the data. One can use logical models to communicate with business. Physical data model includes all the required tables, columns, relationships, foreign keys, primary keys, and database properties which are for the physical implementation of database for a specific RDBMS like Oracle, SQL Server, or Sybase. Database performance indexing strategy, physical storage, denormalization is also important, and this is the place where all this happens. Physical considerations may cause the physical data model to be quite different from the logical data model. There is a compromise as we move or as one moves from the logical data model to the physical data model due to technology influences. Physical data model design tuning. The objective of tuning a physical data model is to avoid unnecessary I/O, avoid data or index hotspots, avoid excessive overhead of insert and update, avoid unnecessary database table maintenance problem, achieve predefined performance target, and work well within the deployment environment constraints. It is this constraints or this particular objective which influences the physical data model and which actually contributes towards a physical data model being drifted away to be much different from the logical data model which we create. So the difference between the logical data model and physical data model is left to your interpretation. Logical data model is RDBMS independent while the physical data model is RDBMS dependent, and the physical data model is driven by DBAs who drive the model. Over here, it is the business expert who drive the model. These are the differences between like a primary key in a physical model, okay, is actually converted to a primary key and a primary key index during implementation. Similarly, a foreign key should be converted or must be converted to a foreign key and a foreign key index. Same is the case for an alternate key. An alternate key index or unique or a unique non-primary index is created for an alternate key. So this is a group. These are certain things which we need to keep in mind and then model our physical data model accordingly. Normally, for an alternate key, we do not first of all go on to designate a candidate key as an alternate key, and when the alternate key is designated, it actually transforms into a unique non-primary index. Validation rules are actually depicted through constraints and referential integrity, and subtype relationships are through the normalized table. Many-to-many relationships are resolved using associative tables. So I leave the rest of the things for you to interpret. Common guidelines. Each and every entity should have detailed information. Entity definition should have reference to pertinent use case, FSD or BRD, as the case may be. Model properties should maintain IE notation as opposed to IDF per X for physical data model. Appropriate domains have to be defined for all possible data types and all possible generic entities like employee ID, insert and update of timestamps, etc. Domain models actually go a great way in providing consistent data type definition across the various places where an entity is being, where an attribute with the same name is referred to. Same is the case with the naming standards. They also help a great way to have consistent naming standards across the data model, and it would be very confusing if we are not having a naming standard and two attributes which means the same thing but have different names and in the data model. A single entity should not span across the pages. Entities should be clearly visible at the display level of attributes and should not overlap on each other. This is from the perspective of representation of or the visual representation of the model. The relationship line should be clearly visible and should not run beneath the entities or should not be hidden under the entities. Very large ERDs has to be divided into subject areas for better visibility and communication. Avoid nulls in potential search predicates. Such attributes must be marked as non-null. Prerequisites of a physical design activity are a logical data model, the volumetric information of the model, DBMS specific features, performance requirement or the NFR document, usage model, that is the data access method, and the audit requirements. So the usage model is something which we do not ask to the client, and it is something which we have to understand as the business requirement becomes clearer and clearer. However, one can ask for a usage model if for greater understanding of the physical database and what is expected out of a physical data model design. So do consider usage model, audit requirements, NFR documents, volumetrics and DTMS specific features as you go ahead to convert a logical data model into a physical data model. So physical data model process is as over here. We have already seen it. Check the scope of the denormalization and need to and the denormalization need and justify them. Identify denormalized strategies. Validate the denormalized data model and identify storage requirements. Okay, these are the steps to convert. Who is required? What are the inputs? What is the activities which takes place? And as you go from logical data model to physical data model, and what is the exit criteria? So an exit criteria is always very important because it defines when a particular task is complete. It marks a completion of a particular task. So exit criteria is physical data model approved by stakeholders. It is not just the physical data model completed and given to the stakeholders, but it is approved by the stakeholders, which marks the end of conversion from logical data model to physical data model. Now steps to convert the LDM to PDM. Again, we will see the entities converted to tables, attributes to columns, relationships to foreign keys. Physical data model can change from logical data model based on the physical constraint and the usage requirement, like the access and performance requirement, concurrent users requirement, volumetrics, logical key groups, reporting requirements, and calculated and derived tables, derived data which are there in the database. After taking a survey of the logical model, following objects can be designed in physical model, that is the partition, table space, file groups, tables, columns, and indexes. Again, partitions are and table space nowadays can be modeled using storage model and even in the logical database as well. In the logical data model as well. Denormalization of physical model is done to accomplish certain specific performance related goals. It cannot be done without a thorough understanding of the data and the needs of the customer. Denormalization is intentional violation of the normalization rules, and since it's an intentional violation of the normalization rule, it is a must to document the justification for denormalization in favor of performance. Denormalization is a trade-off between the storage requirement in favor of performance. That is, it is voluntarily addition of redundancy within the database. DDL scripts are generated from the database are generated for the physical data model. They are responsible for forward engineering the physical data model into a database. It is executable script of metadata. It is created and executed by DBA. to change the database catalog. NFR requirements, non-functional requirements are often called qualities of a system. That is, NFR contains constraints and qualities. Non-functional requirement document is one of the most ignored document, and which can actually, when it comes into picture, it can change the data model by beyond the imagination of a data modeler. Other terms for non-functional requirements are constraints or quality attributes or quality goals, quality of service requirement or non-behavioral requirements document. So these are all means the same thing. It just means non-functional requirement of a data model. So non-functional requirement specifies the criteria that can be used to judge the operation of a system, while functional requirement defines the specific behavior or functions. There are a few pitfalls in NFR. Ensure that the stakeholders understand the cost of requirement, and also ensure that when you go on to collect the non-functional requirements, they understand the value of your questionnaire. If you go ahead to ask that whether the multiple language support is required, normally they would not say yes, but sometimes just for the sake of saying they may end up saying yes, and the cost of requirement may increase because additional second language or third language support or multiple language support will require certain changes to the data model and addition of certain columns within the data model so as to map an English language to or an English text or comment to a different language. Over here I have tried to show a few examples of the non-functional requirement, that is recovery or recoverability, performance criteria, reliability, extensibility, audit and control, compliance, documentation and disaster recovery. This is one of the most important NFI requirement, along with the performance or the response time dictated by the business. So over here we are trying to show a difference between functional and the non-functional requirement, and I leave it once again to the audience for their interpretation. Let's move ahead with the DBMS specific features. The following are the DBMS specific features which needs to be taken into consideration, like indexing, partitioning, storage parameters, block fill filters, block fill factors like for Oracle PCT free or fill factor equal to 100 minus PCT free. For MS SQL it is always the fill factor. So all these things needs to be taken into consideration as you develop your physical data model. Types of indexes, bitmap, bitree or a hash index, data type, default formats, range, max size, default character set. Most important quality of a data model or of a database is the default character set, because once a database is created, one cannot change the default character set of a database. DBMS, buffer block size, data caching technologies, replication requirements, storage, table spaces, and partitioning options. So these are the various factors, DBMS specific features which needs to be taken into consideration, and we can, based on that, we can have indexing strategies as proactive or reactive indexing. Proactive indexes are created by anticipating which columns will be used most for selection, joining, grouping, ordering, and one can build indexes over such columns. Reactive indexes are created based on optimizer feedback after looking at the query implementation plan and system performance for a particular query. Having a few indexes, having as few indexes as possible is a good way to start on, but only use as many as you need. Okay, so because the indexes come with an inherent overhead during updation and insertion of new records by the DML statements. So order of columns, put the column expected to be used most often first in the index. That is, the most used column is put or is arranged first in a composite index or an index on a composite column. An excessive number of index levels may be an issue with tables that have very large keys. Initially, build a few index based on the database model using the following criteria. So start on with few indexes and as and when required, go on to add on indexes. However, due to proactive modeling, you will create more than those few indexes. You will create a few more indexes, more than the minimal indexes which are created. So as to do proactive tuning based on the volumetric information and the user information or data access information in hand with you. So initially build a few indexes based on the following criteria. The column is queried frequently. Commonly used join columns are not designated as primary key. Which are not designated as primary key can be indexed. Columns on which referential integrity exists can be indexed. Create indexes on tables from which one retrieves less than 15% of the rows. Note, bitmap indexes are not advisable to be created in the OLTP environment as they generate a lot of redo when they are updated. For every instance or for a single row which is updated and it is having a bitmap index over the column, the entire bitmap is revamped and regenerated by the database. So since it's a bitmap, that's how it is. It's a bitwise mapping of all the possible values and their distribution within the database, within the column, and it is stored in the data file headers. So columns with wide range of values are good for B3 indexing, and with those with small range of values are good for bitmap indexes. Columns less suitable for B3 indexes are those with few distinct values and those with many nulls in the columns, and one does not search on the non-null values. So these are the kind of columns which you should avoid to build a bitmap or a B3 index on. That is, which are having few distinct values and many null values, and there is no search criteria based on non-null values. Then there is no point creating a B3 index over such columns.